Okay, so now we'll look at a double linked list based implementation of a stack ADT. So again, as I said, we're going to maintain the node previous to the tail node as the top of the stack. So this is the double linked list, then the node previous to the tail node is this node. So the data 5 is in the top of the stack, and the node that is next to the head node will be then eventually at the bottom of the stack, so 10. So as it travels in this direction, so this is the last data node that you pushed, and then this is a node that you pushed before that, and so on. So 10 is the first data node or data that you push to the stack. So the way you implement a double linked list is this. So you have to have three member variables, the data and the next node pointer storing the address of the next node. So it's a node star because it's storing the address of a node, and previous node pointer storing the address of the node previous to this, what are the node that you're looking at. So the no argument constructor will not do anything to the node, and you have set and get functions for all the three member variables. Okay. Now you'll have the now this is the stack class. You have two pointers to remember. So this is a double linked list based implementation. So you need to store the head pointer as well as the tail pointer. The head pointer stores the address of the head node, and tail pointer stores the address of the tail node. Now the constructor for the stack is like you create the head node and the tail node and assign the address to the head pointer and tail pointer, and set the next node address for the head node to be null. So head pointer arrow set next node pointer is null. So head node's next node pointer is null. Similarly, the tail node's previous node pointer is null. So let me see. This is how the stack will look like, an empty stack that when you just created. We have the head node and tail node. The head pointer stores the address of the head node, tail pointer stores the address of the tail node, and the head node's next node pointer is null, and the tail node's previous node pointer is null. So you have get head pointer returning the address of the head node, and get tail pointer returning the tail pointer, which is the address of the tail node. And if you want to check if the stack is empty, you can use the idea that I just mentioned. Check if the head node's next node pointer is null, or check if the tail node's previous node pointer is null. So you can do either of them. So here I check if the head node's next node pointer is null, return true, the stack is empty, otherwise return false. You can also say tail pointer arrow get previous node pointer and check if it is null too, then that is also okay. So now what I want to talk about is this push operation in a double linked list. Okay. So there are two scenarios we have to deal with. That is whether there is node currently in the stack before the push operation or not. So one scenario is there's no node currently in the stack. So that means the stack is currently empty and you want to push the first data node to the stack. The second scenario is there's at least one node that is already in the stack. So let us look at the code to deal with these two scenarios. So you'll have the push function that for which you pass the data that you want to push. So the first thing you could do is create the new node and set its data. Now remember, this new node is going to be the node previous to the tail node. So that means there's no node going to be, no data node following this new node. So you can set the new node's next node pointer to be null. So that's how you do it. New node pointer arrow set next node pointer is set to null. So that means the new node which is just created, a new node pointer stores the address of the new node, and its next node pointer can be set to null right away. Okay. Now you try to get the address of the node previous to the tail node. Okay, so that's stored at the last node pointer. So you get the address of the node previous to the tail node. Now, if there is no node currently in the stack, so that means the previous node's so the tail node's previous node pointer should be null. This is the last node pointer. So the last node pointer is null, then there is no node currently in the stack, which is corresponding to scenario 1. And so far we have just said the new node's next node's pointer is null. Now we want to accomplish these three things. So let us see how we do that. So once you decided that the stack is currently empty and you are really pushing the first data node, then the head node's next node pointer can be set to this new node pointer, because the head node, so this new node that you're adding is both the last node as well as the first node in the stack. So from the tail node's point of view, this is the first node in the stack, and from the head node's point of view, this is the last node in the stack. So head node's next node pointer can be set to the value of new node pointer. And as well as then also, since this is going to be the last data node in the reverse direction, so the new node's next previous node pointer is null. So that means you're setting the head node's next node pointer to be the new node pointer. So that is the new node, and then the new node's previous node pointer is null, because there's no node going to be previous to this node, because it's the last data node. When you traverse it from the tail node, this is the last data node. So we have set up the link now from the head node to the new node, as well as we have set up the next node pointer to null, as well as the previous node pointer to null. So the only thing we have to do is link the tail node to this new node that we created. So we were in the if block, so we cannot go to the else block. So come out of the if else block, you are doing this here, tail pointer set previous node pointer to the new node pointer. So tail node's previous node pointer will be set to the address of the new node that we just created. So this is if the stack is currently empty. So that means the tail node's previous node pointer was null, which is stored in the last node pointer. Now if the stack is not empty to begin with, then last node pointer will not be null, so you get the else block, and that is this scenario here. So we have so far set the new node's next node pointer to null. Now we need to do the other stuff here. So 4 and 5 are what we have to really think about it. So far, so you see here, the last node pointer will really store the address of the last node in the stack. Okay, so the tail node's previous node pointer is the last node, so that is the value, the address of this last node is stored in the last node pointer. So the last node's next node pointer is currently null, because this is the last data node in the forward direction as you traverse from the head node. So now we have to set the last node's next node pointer to be the value of new node pointer, because the new node is a last node in the forward direction. As well as the new node's previous node pointer should take up the value of last node pointer. So those are two things we are doing. Last node's next node pointer is set to the new node pointer, and new node's previous node pointer is set to last node pointer. And then when you come out of the else, we have to set up the link in this direction from the tail node to this new node. So tail node's previous node pointer set to the new node pointer. Okay, so this way you have kind of linked the new node to this double linked list, and that is in the top of the stack. Now let us look at the pop operation. So again, like at the push operation, there will be two scenarios to deal with in the pop operation. That is, whether the stack becomes empty after the pop, or it's not going to become empty after the pop. So let us look at the code for how to handle this. So try to first get the address of the node previous to the tail node. So tail pointer arrow get previous node pointer will get you the address of the node previous to the tail node and store it in the last node pointer. And also have another pointer called previous node pointer set to null. And the pop data is like initialized to negative 10,000, a very large, very small negative value to indicate if the stack is empty and you're trying to pop, you have to send something to indicate that it's an invalid pop operation. Okay, so if last node pointer is not null, that means there's at least some node previous to the tail node. So that means the stack is not empty. Then if I say go to the else block, that means the stack is currently empty and you're trying to pop out of an empty stack. So that's an invalid operation. So that's where you return pop data. So pop data would not have changed if you did not go into the if block. So it is initialized to negative, say 100,000, then you can return that value to indicate to the user that that's invalid pop operation. So you return from here from the function. Now, if the last node pointer is not null, so that means the stack is currently not empty, there's at least one node in the stack. So try to get the address of the node previous to this last node. So previous node pointer, which is initialized to null, gets the address of the node previous to the last node. Okay, and then also get the data of the last node. So last node pointer arrow get data will be now set the value of this pop data. So why we do this? We want to check whether the stack is going to become empty after the pop operation. So that's why I'm trying to get the address of the node previous to this last node, which is stored in previous node pointer. So if previous node pointer is not equal to 0, that means there is some node previous to the last node. So that means even if I pop out that last node, there's going to be some node in the stack. So the stack is not going to become empty after the pop operation. So if previous node pointer is null, that means the stack is going to become empty after the pop operation. So the last node is the only node in the stack, and you're going to pop it out. So that means you go to the else block. So the stack would have become empty then, and for the empty stack, the head node's next node pointer is null, and the tail node's previous node pointer is null. So that's the thing that you have to do. Now, if previous node pointer is not null, that means there is some node previous to the last node. So even if you pop out the last node, the stack is not going to become empty. Then what we have to do? Then after the pop operation, the previous node to the last node is going to really become the last node in the forward direction. So the previous node pointer's arrow set next node pointer will be set to null. So the previous node will become the last node. There's no next node following it. And the tail node has to be linked to this previous node. So tail pointer arrow set previous node pointer and pass the previous node pointer as the argument. So I'll show that here. So if this is the case, you have the last node pointer pointing to the last node, and the previous node pointer pointing to the node previous to the last node. And so what you're trying to do is here, previous node's next node pointer is set to null, and the tail node's previous node pointer is set to the previous node. This is pointing to the address of the previous node. So that means this last node is kind of now isolated. Now it will be linked to this previous node, but there's no use of it. You cannot access this node at all. You have cut off this link in both directions. So you cannot go to the last node in the forward direction, as well as you cannot go to the last node in the reverse direction. Okay. So that is the pop operation. Both can be done in constant time because you don't have any loop for the push or pop code. You just have to check if some condition is satisfied and then proceed. Now the peak operation, the code is going to be similar to the pop operation, but you're not really isolating the last node. So try to get the address of the last node, which is the node previous to the tail node. So tail pointer arrow get previous node pointer will get to the address of the last node, and to check if the last node pointer is null or not. If it is not null, then return the data of that last node. If it is null, that means you're trying to peek on empty stack, so you have to return a negative value, a low value, to indicate that it's an invalid operation. Okay, so we'll stop with this video.